Hello and welcome to another PlayBASIC tutorial. This time we're going to have a look at a couple of pretty controversial commands in modern programming. One is GOTO and the other one is GOSUB. Now these things are found in the manual, so you can go up to help and you'll find them under core commands. Where are we? Okay, so these are under control changes down here. Subroutines, and of course you can have a look at them there and read the stuff in there, but today's little tutorial is really just about, well, really just to get on screen to look at how we can use these things. Now, what a GOTO does is it makes PlayBASIC, and pretty much any form of BASIC you're using, jump to the label we place after it. So I need to do two things. I need to type in the word GOTO, add a space, and then our label name. If I just type, my label. Now if I try and compile that, we'll get an error. We're getting an error because we haven't told it where this label is. A label is a special marker that's in your program. It has to be left justified and you need a colon after it. Now, we've kind of created a pretty useless program. But, I'll put a sync at the bottom and I'll put a wait key so the program doesn't just end immediately. We'll try and run it again, F5, and we get a dumb looking PlayBASIC screen. Now, at this point we can't really tell what's going on. We need something in between our GOTO statement to show, keyboard mapping, to show that we're actually jumping over something. Now, if we run the code this time, if you're expecting to see the hello world, you'll be horribly mistaken. And there you go. Now, alright, let's have a look at what's actually happening. So when PB comes down, it sees this GOTO statement here. It goes, okay, you want me to jump from this point in the code to wherever this little label here, and it's kind of like a marker in the code. I can put as many lines down here as I like. A whole bunch of print statements. Pull back up on screen so we can see what's going on. Okay, so I have a bunch of print statements there. Now, in really old BASICs, you see the line numbers are on the edge of the screen here, which are really just there as a kind of a courtesy, really. In modern programming, in the gutter over here, in old BASICs, you would actually have you would have line numbers for each line of code, and you would jump to the line number specifically. So if we wanted to jump to, that happens to be line 20, you would put GOTO 20. This doesn't work anymore. You can't do this anymore. Right, it's telling us there's an error and GOTO, the label GOTO is not defined. That's an interesting error. It doesn't know what to do with that literal value. It has to be a label. Let's give it a better name, that label. We'll call this label, what about we call it skip over print statements. Pretty big label to remember, but nice and obvious in the code what's going on. Place the label there. I don't need the colon to call the label, I just need that as part of its identification. So it's not, PB doesn't consider this to be an integer or some other kind of keyword. Right, let's run it again. Check it out. Nothing on screen. So we are jumping from this point here, when PB hits this GOTO statement, jumps to wherever in the code this label is. Now we can jump down the code or we can jump up the code. At this point we're jumping down, so we're jumping from this line here down to here. We could do something like this. We could move that jump in the middle of these print statements, and we would see, well, I have one print statement. So we'll see one hello world, and then all these ones here will get skipped over. And there we go. Now, GOTO is a non-conditional jump. We're explicitly jumping every time we hit this instruction. So any code that's following the GOTO statement isn't going to be executed unless you at some other point jumped back to it. Like you can place a label here, after GOTO. Now if I added a jump statement, sorry, a GOTO statement here, and jumped after GOTO, the program would keep repeating this logic here. So it would come through the first time, skip over. We would see one hello world. If it's there waiting for a key. Once I press a key, it will hit this GOTO statement and jump up to here. And it'll print a bunch of these hello worlds, and then the label itself doesn't actually do anything. It's just a marker for where these GOTO statements jump into. When PB sees them in the code, it just ignores them, just runs straight past them. So PB would see the print statements here, run them in succession, skip over the label, hit sync, and they'll be sitting there waiting for a key, hit GOTO after I press a key, and we just keep doing that forever. Once this thing starts, it won't finish. Let's try it out. Right, so the first time we've got one hello world statement. Now we've got heaps of them. Luckily I can escape out of that. So GOTOs are non-conditional branches, and the jumping, I should say, and the jumping is forever. PB has no way of knowing we ever want to come back from this point. Another kind of branch, which is also known as a subroutine, is the Gosub. I might leave that in there. Right. And Gosub has the same requirements. We have the keyword, and we need a label after it. If you want help on Gosub, for example, you just put the cursor on it, press F1, and go to that particular help. There's a fair bit of stuff on this one here. Now, Gosub is similar to GOTO, and we need to give it a label, but it's actually designed for things called subroutines. I had an end statement. I don't want the program to run what's after the wait key. I want it to hit this point and then finish. I'll call this label my sub, and we'll print. So we'll put a label up against the left hand side. We'll print my first subroutine. Now, if I ran this, we would actually see the thing would pretty much just flash on and then disappear and return. As you can see, if I run it again, same thing. The reason for it is that PB is coming down, doing our print, doing the GOTO, jumping to this point, hitting the Gosub, and jumping to this subroutine here. But we haven't told it that where the end of this subroutine is. Now, subroutines are kind of a way of making where we have small pieces of code that are outside of a loop. They've kind of been replaced by functions and in P-subs in PB, really, or in modern programming generally. So they're kind of like legacy basic approaches, but you can mix and match the two. You know, some people don't like the use of GOTO and Gosub, that's fair enough. But you can do it. It's not the end of the world. Gosub expects at some point after this label you're going to use what's called the return command. This is the pairing. So Gosub statements have to be paired with a return statement at some point. The mechanics of how Gosub works, I'll go through that in a second, but now this time we're calling this subroutine, which means we're jumping down to here, this label, running whatever code is after that, hitting the return statement, and now this return will actually this time jumps us back to the line after the Gosub. So we can break away from this main flow of code, do something, and then return back to the main flow, continue on. This time we will see, there we go, our print statement at the top, and we've got our subroutine working here as well. Let's put that into a for next loop or something like that, so we can see this thing is, we're calling and returning. So we'll loop the thing, I don't know, that many times, 10 times. If you're not up to date with for next loops, go and have a look at one of the other tutorials on for next loops. Get an idea of what's happening. This time we've got a loop here, and every time we process through the loop, we're going to be calling the subroutine, doing this thing here, which is the print statement and returning. So it's going to print that message 11 times. Yep, I said 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh. Aha, look at that. We have an error. Why is it giving us an error? What on? Must be some bug in PlayBASIC. Well, it's not actually. We have to kind of go back a bit to understand how Gosub works, to understand what this error here. It's telling us there's a stack underflow. That's because we haven't got an end statement in here. Now, before I was talking about when we have labels, when PB sees a label in the code, it doesn't care about it. It doesn't think that's not code, it's just a marker within the program. So people would, if it sees a label, it just skips straight past it. It remembers where that location is within the code, but it doesn't generate any actual code itself, the label. So let's go back and go over the mechanics of Gosub. Previously I talked about that Gosub statement, when it's executed, jumps to the location where the label actually is within the program. Now it does something else too, is it actually adds what's called a breadcrumb, really. It adds I guess for simplicity's sake, we'll say it adds the position of the next line of code after this Gosub statement onto what's called the stack. The stack is it's just a heap of a piece of memory that's used like a heap. Things are thrown onto the stack, generally in a temporary fashion, then retrieved from the stack. And the idea is to have the stack always at 0. If we try and retrieve information from the stack that's empty, we get an underflow, and that's what's happening here on that previous program. Anyway, so when a Gosub statement is called, it adds to the stack the position in the code after the Gosub statement. That's important to note. And then it jumps to this label here. So it would go, okay, works out where what the next line is in the code, pushes it to the stack, and then jumps to the Gosub, the label's location, which is my sub in this case. Continues on executing as normal. So the code here has got a print statement. We run the print statement, then we hit this return statement. Now this is the statement that is paired with Gosub statements. It's the mechanism that retrieves an old retrieves the location of where we have to jump back to from the stack. So when we jump to my sub, on the stack we've got one value. That's going to be this location here. When we get down to here, we're going to pop this value, which is pop just means to grab the top value on the stack. Since it only has one value, we're going to grab that value and we're going to use that as the return location, or the jump back to location. So return is kind of like a goto statement actually, that is using the stack mechanism to retrieve where it has to go to back, where it has to jump back to. Wow, that's pretty clumsy clumsy explanation, I think. Hopefully that sort of makes a bit of sense. So if we did something like this, here we're calling it the Gosub once within the routine. We call it these 4 times. You can work out how much stack data is required. It never needs more than one stack value, because this goto statement is going to push data to the stack. So we've got one value on the stack. It's going to go run this bit of code here and then returns it, emptying the stack out to 0. Okay, but if we had another Gosub in here, let's say we print this. We go let's say we jump to a second routine called my second sub. And we'll print something out here as well. I don't know. My second subroutine. Creative. We need that return statement on the end there. Very important to have that. This time we actually do have multiple values on the stack. So if we go back at the top, we're entering our loop. We're hitting the call to my sub. It's pushing the return value to the stack at this point and jumping to my sub. Starts executing this, all good. Hits another Gosub statement. Now the stack already has one value on it. That's the return value from my sub. This original call here. But now we want to Gosub somewhere else, which just happens to be the next line below it. You wouldn't do that in real life, but hey, it's an example. So this Gosub here is pushing the next line, which is this return statement anyway, to the stack. So we have 2 bits of data on the stack, and then jumping down to here, my second stub. So we're doing this print, all cool, and hitting the return. So we've popped the stack once. So that last value pushed on was this value here. So it will return back to line 17 in this case. Runs this code here, hits the return, and that return will bring us back to line 8 up here, emptying out the stack. Pretty crazy. Oh, there we go. Now I suspect people would think that's a bug. It's actually not. It's intentional in PlayBASIC. Saying that the label wasn't defined, that's because PB has very strict rules about how labels can be used. It's kind of one of those things that's a bit of a kind of upset people. And one of the reasons why people don't like Goto, in PB, labels have to be right up against this left edge. If it's not, if you're trying to indent it, it won't see it as a label at all. When it hits this bit of code here, it won't have a clue that my second sub is defined. That's intentional. It means that you then can't go putting labels in strange places, and I'll probably should do a bit on that when we talk about functions. Anyway, run it. There we have. We've got my first sub, my second sub, my first, my second, my so on, all the way down. Okay. Now, if you're wondering why we probably not sure that I covered why we had a stack underflow earlier. If I remove this end statement, if we look at this loop here, well, we'll get rid of the loop altogether and just have really bare bones. So we're calling out our subroutine. So we're pushing some data to the stack, doing this subroutine here, doing the second subroutine, jumping to that, doing its work here, returning back to here, then returning back to the original call, doing a sync, and then waiting. When I press a key, what's going to happen is maybe it's going to move past, down, fall down to here, call this GOSUB, it's going to run this subroutine here, return, and then hit a return statement. Now, the stack at this point won't have any data on it. It'll only have, it'll be empty. So you actually get a stack underflow error, just to verify that's the case. So if you're running your program and you're getting one of these errors, it means at some point you've missed a GOSUB. That's pretty much what it's telling you. That's why I was using the end statement here. So after I hit a key, we're telling the program to just finish. We're done. Quit. Okay. So there's a couple of other types of statements that we could use, and these are kind of a little bit more advanced. These are the on Gosub and on Goto variations. Now, probably one of the reasons why people don't like Goto in general, or even subroutines today, is that we have other mechanisms now that emulate them, such as the functions, S functions or P subs, which is a protected subroutine, which is kind of a mechanism that kind of emulates what this does, but it looks like it's a much more modern looking solution. So we can branch away from this main piece of code and do something and then return. So this time we're calling my sub, which has just a print statement and a return. Then when we get back from this first call, we're going to call here, get pretty much the same output as before. Okay. Let's have a look at, we might use a goto statement. Hopefully you've looked at sort of loops a little bit and kind of familiar with those things, or we'll just have a little. Now, I'll kind of make an example where it's probably not. Well, sorry, I'll kind of show you a comparison. Rather than actually have our main do loop in our program, I'll just make the inner loop here do something. We'll draw a circle at the mouse coordinate. .30 and true. Alright, so we run this thing here, drawing kind of a blob wherever the mouse position is. Hit escape and we're out now. Now, all the basics didn't have do loops. Probably some variations of them do. What some people might like to do actually is, people who come from those languages, they like to actually have this kind of structure. So you have like a main loop up here, and then you have go to main loop at the bottom. This replicates the same behavior. The program starts executing, does a clear screen, draws a circle up with the mouse position, flips the back buffer to the front buffer, hits the go to and jumps up to here, and just keeps doing that forever. Yeah, because I've got sync in there, that's actually how the window is aborting. We can turn that behavior off if you really want to, but while you sort of learning it's very useful. We couldn't use GOSUB here, and the reason for this is we should actually get a stack overflow if we do this. We'll try it and we'll see what happens. So it's running for a bit. Wow. Yeah, it's giving us a bit of an error there. We're running on sort of a beta version of PB in these videos, and the betas don't have all the same error trapping that the general runtimes do. But what an overflow is that the stack has a limited space in memory, and at some point, if you keep pushing stuff to it, it just overflows, and PB normally can detect those things and stop them from crashing like that. Okay, what I was going to do is let's say, I don't know, let's say if you want to press the mouse, let's say if you click the mouse button and you want this thing to end the program, you could use a GOTO here. You could go to, as long as your label is outside of this loop and below it, end my program, we'll call our label. So it's like the label is just like a position, a marker in the code. So when I press the mouse button, the program is running. This condition is going to be true. If statement's going to fall through, hit this GOTO there, and it's going to change control. It's going to jump to wherever this end label here is, which is down here. Since that's at the end of the program, the thing's going to end. Let's try it out. All good. Click the button, and there we go. Yeah, I mean, some people don't like those things, but it's just the way it is. One other mechanism we do have is probably a little bit more advanced, I guess. It gives us, well, it's the on GOTO or on variable GOTO, which is kind of another way of doing so if I have my variable there, GOTO, and then I want I need a list of labels at the end of it, 2 and 3. Explain what this is going to do in a second. I don't really have any preconceived ideas of what it's going to do. It's going to write something and then try and get it to work for you. Put a sync at the bottom. I don't want this thing to stop. Let's pull this stuff inside a for next loop, just because, hey, we can. We'll make this loop go from 0 to 3. So what onGoTo does is it uses this variable here as the offset into a table of labels. As long as you've got, in this case, loop is going to be a value between 0 and 3. So as long as it's within range, it's all going to be good. And so in other words, what's going to happen is that when loop is 0 the first time through, it's going to go to label 0, which is here. just print 0. Now, what we were saying before about PB just ignoring labels, you might notice that we'll just hit the label and just go straight past it. So when if loop is 0, it will actually print all of these values here. I might just pull it out of the phonics loop so you can see that for sure. Loop is 0. Oh, clumsy. Run the thing and it's displayed all of them. If I change loop to be 2, we should get 2 and 3. There we go. That's because it's when loop is 2, that's index 0, that's index 1, that's index 2 in the table. That's so GOTO is jumping to label 2. This one. The printhead has no other control changes after it, so it just falls past and prints 3. If we had another GOTO, end of jump table, which is really what we're making here, by the way. We're making a jump table. So you can kind of control the core mechanics of how this thing works. This time we won't get the extra values. So we'll just display 2 for us. There we go. If we put 4 loop into those, alright, into a next statement. This thing's getting pretty long, so I don't really want to keep bashing you around the head with it. Let's run again. And we get all 3. So first time through in the loop is 0, so it jumps to loop. This part in the table jumps on this label here. When we loop again, loop is going to be 1, and it uses label 1, which is down here. So we print 1 on the second time through. If I print loop here, it's probably easiest to see that. There we go. So when labels 3, we're jumping to label 3 down the bottom. And it kind of simulates I guess a select case statement in sort of modern programming speak, which some old basics didn't have, but some of them did. Okay, hopefully that gives you some ideas about what these things, or even some reminders about what's actually you can do with these kind of really basic ideas. You can use there's a variation of this as a Gosub statement too, by the way. To make this work as a Gosub, you would need to put a jump here and returns after these statements here. These wouldn't even need to be in here actually. It makes more sense for them not to be in there. Just have a return statement there. Return here, get rid of those. How messy is that? Pretty messy. Don't need this statement here at all. I better put an end there, otherwise we'll get a stack underflow if we run that. Same behaviour, and we're happy. So you can use the same mechanic to call a list of subroutines on whatever some variable is. I've used that in the past to do things like in things like sprite collisions, that kind of thing, where you might have different character numbers, and that character number is just then in a list of those things. Other people use them in select case statements. The principle is pretty much the same. Well, I think that will have to do us. We've covered some pretty boring stuff today. I'm sorry about that. It's hopefully it just gives you some idea of what these kind of statements do, and my bumbling wasn't too hard to follow. Anyway, thanks for watching, and hopefully your programming is starting to progress, and just keep it up. Bye.